Hello and welcome back. We are going to be working today on Chapter 4, Section 2, Simplifying Algebraic Expressions. Okay, I need for you to recall that you know how to write an algebraic expression. We learned that in Chapter 1, Section 2. And today we're going to be identifying the parts of an algebraic expression, as well as using the distributive property to simplify algebraic expressions. Your new vocab term today is term. That's anything that is separated by a plus or a minus sign. Coefficient. This is the number written right in front of the variable. It's not added or subtracted. It is the thing that's being multiplied to the variable. Like terms are terms that have the exact same variable or variables in them. The constant is a term that contains only a numerical value. Simplest form just means that you have combined all the like terms. Simplifying the expression is the process you're going to go through to get things into simplest form. Okay, so first off, we're going to begin by identifying the like terms in the expression. Remember, like terms, we are looking for terms that have the exact same variables. In this case, we have 1, 2, 3 terms. The sign in front of the term is part of it. So this is a positive 4x, positive 1y. Remember, there's a phantom 1 here. It's understood that it's there. And this is a positive 7x. 4x, positive 4x, and positive 7x are like terms because they have the same variables. The term plus y is kind of a loner here. It doesn't have any terms that are like it. Okay, as we look at this expression, we have a positive 3x, a positive 8, positive 2x, and a positive 1. So there's a total of 4 terms here. I'm looking for like terms, so I'm looking for things that have the same variables. Easily you see the positive 3x and the positive 2x. But I need for you to recognize that positive 8 and positive 1 are also like terms because they are constants. So we can add 1 and 8. You get 3x and 2x, of course, are like terms, and 1 and 8 are like terms. Okay, now try this one on your own. You should have selected 3x and 5x. Notice there's 1, 2, 3, 4, 5, 6 total terms. But only 2 of them are alike because they share an x. They have an x in common. Okay, try this one. This time you should have chose choice C. Once again, there are multiple terms here. In this case, we have 1, 2, 3, 4, 5 terms. The 3m and the positive 4m are like terms because they have the m in common, but also the positive 6 and the positive 5, your 2 constant terms. Okay, now we're going to look at identifying the terms, the like terms, the coefficients, and the constants in this expression. Okay, notice that what they do here is first they rewrite your subtraction as addition problems. Okay, so instead of minus x, you have plus a negative x. Instead of minus 3, you have plus a negative 3. Okay, and when you do that, you can clearly see that there are 1, 2, 3, 4 terms. Notice here that they rewrote this as negative 1x because remember, there is always a coefficient of 1 in front of your variables even though you don't see it. Okay, so here you go. First thing you had to do was identify the terms. They are 4x, minus x, positive 2y, and negative 3. Now when we go back and look to see what the like terms are, They were only 4x and negative x, or negative 1x, because they both have an x variable in them. Now let's look at the coefficients. The coefficients, 4, because it's being multiplied by the x, negative 1, because it's also being multiplied by the x, and 2, because it is being multiplied by the y. The negative 3 then is your constant. It is a constant value. Negative 3 never changes. So when you're trying to remember all of these terms, think about your constant term as being the term that never changes its value, whereas something like 4x and negative 1x and positive 2y will change depending on what x and y happen to equal. So those terms will vary. They have a variable in them. They will vary, while the negative 3 term will remain constant. Okay, try this one on your own. You need to identify the terms, the like terms, the coefficients, and the constants. Here you should have chose C. Okay, now we're going to simplify the algebraic expression. Remember we talked about terms. There are 3 terms here. When you're simplifying algebraic expressions, you want to identify your like terms. So in this case, I know that 8n and 4n are like terms. When I have like terms, I can combine them. So I have a positive 8n and a positive 4n. I can go ahead and combine those to make a positive 12n plus 4. That constant term of plus 4, I cannot combine it with anything, so it just gets attached to the end. Okay, here's another one. Now, notice here I have 1, 2, 3, 4 terms. Okay? The 6x and the 5x are like terms. So are the 4 and the negative 7. Okay? So combining like terms, I'm going to take the 6x and I'm going to add to it a negative 5x. I'm going to take the 4 and add to it a negative 7. Here you can see they're starting to combine things. Okay, 6 minus 5 gives you 1, so you end up with 1x. 4 plus a negative 7 gives you a negative 3, so you can write this as x minus 3. Here's another one. This time, notice you have the negative 2 in front of the parentheses. So we're going to use our distributive property that we talked about in section 1 to get rid of these parentheses. Okay, notice first thing that they do is they write this y minus 2 as a y plus a negative 2. That helps you remember you need to take that negative 2 through the parentheses. So you're going to have y equals negative 2x plus a negative 2 times a negative 3y. When you simplify that, you get a positive 6y. Okay, now I'm looking to combine like terms. I have a y and a positive 6y. Basically, remember there's a phantom 1 here, so you're adding 1 and 6. There they are. And you get negative 2x plus 7y. Okay, now it's your turn. You should have made choice B your answer, as it's 5x and 7x are like terms. 5 plus 7 is 12. Try this one. This time you should have gone with A. Your like terms are 3m minus 1m. 3 minus 1 is 2m, so you would have been looking at only choices A and B. Positive 9 minus 6 is a positive 3. All right, here you go. Try this one. Okay, remember you want to take this negative 2, the sign in front of the 2 is part of it, so negative 2 times the things inside the parentheses. So you'll end up with a negative 6r, and then you'll end up with a positive 8. Your choice should be B. When you get the 3r and the negative 6r, 3 minus 6 is negative 3. So that's how you end up with that negative 3r. Okay, write and simplify algebraic expressions. Suppose you and a friend worked in the school store last week. You worked 4 hours more than your friend. Write an expression in simplest form that represents the total number of hours you both worked. Okay, so here they are writing everything out. In words, you're taking your friend's hours plus your hours. We don't know how many hours your friend worked, so we're letting that be the variable h. We know that you worked 4 more than your friend, so I'm replacing the number of hours your friend worked with h, and the number of hours you worked with h plus 4. Okay, so here it is. I've got h plus 4. I'm going to use the associative property to change my grouping symbols here. Notice it's still the same order, h, h4, h, h4. And that's a 1h and a 1h. Remember, there's a coefficient of 1 in front of there. 1 plus 1, last time I checked, is 2h. So you have 2h plus 4, and that's as simple as we can get it without more data. Okay, and this one is yours. Good luck. You should have made choice C your answer. Let B be the number of books you borrowed. Then B plus 3 is the number of books your friend borrowed. When you combine B plus 3, you end up with 2B plus 3. And that's the end of the lesson.